I'm going to try and go nice and slow and just make sure I answer all of your questions. I suggest that you get out your times table. And I'm actually going to insert one right here because I want to show you something about them. So if you don't have your times table out, grab it, if you would. Insert a file. So there's just something that I want to show you about a times table. Okay. All right, so we're going to start off with the difference of two squares. Do you guys remember what the acronym, the little like saying for the difference of two squares was? Dots, yeah, dots. We don't use that in Indiana, but we use that here in North Carolina. Difference of two squares, okay? You recognize this because they only have two terms. It's something like x squared minus, difference means subtraction, 4. They have two terms and there's a minus sign between them. And both terms are perfect squares. X squared is a perfect square. It came from taking x times x. And 4 is a perfect square. It came from 2 times 2. Okay? So I thought we could list all the perfect squares, but I'm hopefully going to do one better for you. Everybody look at their times table. Your perfect squares are the what? Where are your perfect squares on your times table? What is this? Yeah, it's the diagonal, right? It's the diagonal. It's all of this. So we went up to, this is a 25 by 25. So I'm going to go all the way to 625 because 25 times 25 is 625. I recommend that you have your perfect squares up to 25 memorized, but you know what? That's fine if you don't. But I would try to at least know them up to 20, 18 squared, 19 squared, but it'll just help you with factoring. It'll help you with factoring it really well. They're on the diagonal. So circle them, highlight them, whatever you want to do, but they are the diagonal. They are the diagonal of your times table. There are highlighters in the student center over there. If you guys want to highlight them, you go right ahead because I'm going to let you use your times table. Even when you get to use a calculator, you'll still get to use your times table. I just think it's a good resource. Okay. So let's list a couple of them. I don't know. 1 is a perfect square. It was made by taking 1 times 1. 25 is a perfect square. It was made by taking 5 times 5. 64 was made by taking 8 times 8. 225, 15 times 15. They're just on the diagonal, and that's what I wrote on my copy. If you have a copy of filled out notes, I said it's on the diagonal. The diagonal of your times table. It is on the diagonal, okay? So I just want you to know that. It's on the diagonal of your times table. Remember that there's a shortcut. So what those look like when you have the difference of two squares like this, x squared minus 4 or x squared minus 36, you learned that those were, we called them special cases. That came from x plus 2 times the quantity x minus 2 or x plus 6, x minus 6. Meaning that you just have the square root of each term joined by a plus and a minus. What's the square root of x squared? X. What's the square root of 4? 2. So when you factor it, you're just going to take it and join it by a plus or a minus. Okay? When we do that, when we have two binomials that have opposite signs, same numbers, same variable terms, but opposite signs, those are called conjugates. That's going to be important to know when we start imaginary numbers. They're called conjugates. So we're going to use this idea. We're going to use this idea of taking the square root, since they're perfect squares, of both the front and the back of our two terms. So let's see. What is the square root of m squared? It's m. And what is the square root of 49? It's 7. So this factors out to m plus 7 times the quantity of m minus 7. Does that make sense? Why does that work? Well, because when I FOIL these, I get a positive 7m and a negative 7m, so that those middle terms cancel each other out. That's why that works, okay? Let's look at example 2. What is the square root of 4t squared? What's the square root of 4? 2. And t squared is t. What's the square root of 25? So I'm going to factor this out to be 2t plus 5 times what? Yeah, 2t minus 5. Okay. Are we good with that? Okay. Let's look at the next one. What is the square root of 64m to the 4th? And what's the square root of 9p to the 6th? So let's talk about 64. What's the square root of 64? And what's the square root of m to the 4th? M to the 2nd. Yeah, notice for the powers on a variable term, you just divide that exponent by 2. So what's the square root of 9? And p to the 6th, I just take that exponent and divide it by 2 is p cubed. So this is going to be 8m squared plus 3p cubed times 8m squared minus 3p cubed. This is difference of two squares. Difference of two squares. Does this make sense? Okay. So what am I going to do for this last one? Dakota, you walk me through the whole thing. Yeah, what is the square root of 169r squared? Look, it's 13. So 13r. What is the square root of 256? It's 16. So what's this become, Haley?
13r plus 16 times 13r minus 16.
Yeah. How do you feel about that? How do we recognize this? How do I recognize that what's special about this, and how do I know that it factors into this? Two terms, and they're both what? They're both perfect squares. So you have a quadratic with two terms. They're both perfect squares, and they're joined by a minus sign. That's how I recognize it, okay? That is how you recognize dots. Two terms. I hate that that red doesn't show up for you guys. Two terms, they're both perfect squares, and they're joined by a minus. Okay? Do you feel okay with that? Okay. Perfect square trinomials, you recognize this because it factors into a binomial times itself. So patterns that you see are, well, the first thing that you notice is that C is a perfect square. That's the first thing that you notice, but I'm going to put over here A is also. But really, you hopefully notice that C is perfect square. So it's written in standard form, ax squared plus bx plus c. So hopefully you notice that C is a perfect square. The other thing is, let's talk about the B term, that middle term B. B is made by taking 2 times the square root of whatever A is. Typically it's an x squared times the square root of your C term. That's how you recognize those. Okay. So we're going to practice looking at things that follow that pattern. We're going to practice looking at things that follow that pattern. So it's a binomial times itself. Well, let me show you what that means. That means like x plus 4 times x plus 4, which we write how? X plus 4, the quantity squared. Yes. Okay. That's what we mean when we say a binomial times itself. Okay, so when we end up factoring it, it's going to end up looking like this. It's going to look like this. Okay, so let's jump into one of those. So my leading coefficient for example number 5 is 1. 1's a perfect square. So the square root of x is just what? Or sorry, the square root of x squared is x. So we really just need to think about what is the square root of 9? It's 3. So I know that I'm going to have a 3. Let's see. If I take the square root of 9, I know it's 3. If I take 2 times 1 times 3, do I get this b term?
Yes.
Yeah, I do. So that's how I know that this is a perfect square trinomial. So it just factors out to x plus 3, the quantity squared. I can FOIL it out for you if you want to see it. X plus 3 times x plus 3. X times x is x squared. 3x plus 3x is 6x. 3 times 3 is 9. Okay. Does that make sense? So let's look at the next one. What's the square root of 49?
7.
It's 7. Okay, so I'm going to do 7 plus. Let's look at this b term. Does b equal 1, which is my square root of a, times 2, because I said you take 2 times that, times 7. Is that what b equals?
Yeah.
Yeah, it is. So this is just x plus 7, the quantity squared. What about example 4? I don't know if this is a perfect square trinomial or not. What's the square root of 9? It's 3. What is the square root of 4x squared? 2x. Okay. So b should equal 2 times 2x times 3. Does it? What's 2 times 2x? Times 3 is what? 4 times 3 is 12, right? Is that what my b term is? Yeah, it is. So this just factors out to 2x. That's what you got when you took the square root of 4x squared. 2x plus square root of 9 is 3. Quantity squared.
Wait, so the 12 has like, it doesn't.
No, because if I were to FOIL this out, look, Dakota, if I were to FOIL this out, I have to take 3 times 2x, which is 6x. But I also have to take 2x times 3x, which is, or 2x times 3, which is 6x. These add together to get your 12. Does that make sense?
Yeah.
Good question. I want to alter number 9 a little bit. I want to alter number 9 just because all of these look the same and I want you to see something different. So I'm going to write that as a minus. I'm going to write that as a minus. Well, I'm trying to, but it keeps erasing my white marker. I'll put it right there. So same idea. Let's take the square root of 16. What's the square root of 16? It's 4. What's the square root of 9x squared? 3x. Okay. So what's 4 times 3x?
12x.
Times 2 is what?
24x.
It's 24x. So the only difference is that this has a minus in front of it. What does that mean? What's going to go in the parenthesis? A negative. 4 is your first or your last term. 3x is your first term. And that works because negative 4 times negative 4 is positive 16, but you have a negative 12x when you spread it out, added twice. Do you guys see that? Raise your hand if you need me to FOIL that out so you can see what's happening, because I will. Okay. So when I FOIL this out, I get 3x minus 4 times 3x minus 4. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. -4 times -4 is
-6.
a positive 16. Yeah, what happens to those two -12s in the middle? Yeah, they combine to make -24x, which is what you started with, okay? So I think it's harder to, it doesn't jump off the page at you when your leading term is not 1, but it still works the same way. Just remember to take the square root of the first term, the square root of the last term. If you multiply them together and multiply that by 2, if you get the b term, it's the perfect square trinomial, okay? We're going to practice it. I promise you, we're going to practice it. I think I've got 8 practice problems. Okay, zero product property. The zero product, this is the third time we've had this exact blurb written in your notes. The zero product property says if the product of two factors is 0, then at least one of those factors is equal to 0. That's how we solve a quadratic. Why do we do that? Well, I just want to kind of remind you about your graphs. This is y equals ax squared plus bx plus c. If we set this equal to 0, we're just saying y equals 0. What happens to a graph when y equals 0? I cross the what? The x-axis. That's why this is working. We're finding where it crosses the x-axis, which you know is a solution. You already know that, okay? That is like the whole point of this, is to be able to identify the roots, the zeros, the solutions of a quadratic, okay? So for this first one, let's see. How many terms are there? 2. Okay, so if we have 2 terms, the first thing I want to do is check and see if they're both perfect squares. Are they? Yeah. Are they joined by a minus sign? Yeah, they are. So I'm just going to take the square root of both terms. What's the square root of x squared? X. And what is the square root of 25? What do I put in the middle of those two binomial? 1 gets a, and 1 gets a. Yeah, don't forget that, okay? But remember that we're solving now, so they both equal 0. So what does that mean? Well, that means that x plus 5 equals 0, or x minus 5 equals 0. Which means my solutions are what? And? Good job. Yeah, if you can skip this step right here, do it. I'm hoping that you guys can get to that point where you don't have to write that down every single time. Okay? Let's look at example number 10. How many terms do I have? 2 terms. Okay. Is the leading coefficient, like the a squared term, is that a perfect square? Yeah, it is. What about the last term? Okay, so what is the square root of 36? So that's going to be 6x. 6x. What is the square root of 49? 7. 7. What do I put in the middle of both those binomials? 1 positive, 1 negative. Why do those cancel each other out? Those binomials have a special term. They're called what? It begins with the letter C. And I highlighted it. It's real close. Conjugates. Conjugates. Yeah, good job. +1, dude. I got to write that down before I forget. Aubrey, +1. Okay. Called conjugates. All right. Let's look at example number 11. Doesn't have 2 terms. It has 3 terms. So I want to check and see if this is a perfect square trinomial. This is a perfect square, meaning is it going to end up like this? Well, I have to look at this term, and I have to take the square root of it. What is the square root of 25? It's 5. My leading term is 1. The square root of 1 is 1. So if I take 5 times 1 times 2, what do I get? Is that what my b term is? Yes. So this is a perfect square trinomial. X plus 5. Oh, that says b, sorry. X plus 5, the quantity squared. Can you stop that, please? Thank you. X plus 5, the quantity squared. What do you think about the next one? We have to take the square root of 4x squared And I need to take the square root of 81. That'll tell us what to put in our parentheses, and then we just need to check it. What is the square root of 4x squared? 2x. And what is the square root of 81? 9. Okay. 2 times the square root of a times the square root of c. What is 2 times 2x times 9? It's 36. That's joined by a minus. So what does that tell me I need to put in my parentheses? A minus. It's going to be 2x minus 9, the quantity squared. And remember in our notes, we proved that that works. But this equals 0, and I forgot to do that on this one. So this equals 0, so that means 2x minus 9 equals 0, or 2x equals 9, or divide both sides by 2, x equals 9 halves. And for this one, I didn't solve it. X plus 5 equals 0, which means x equals negative 5. Why don't I write x equals negative 5 twice, even though it's crosses through the same point? That's why I don't write it. How does this look on a graph? It looks like this. It just bounces. This bounces. Compared to something like this that goes through at 2 spots. Okay? Perfect square trinomials just bounce on the x-axis. They just bounce. Questions about that? Okay. So here's where we kind of start to put it all together. So let's talk about all the methods that we've learned. Number 1, whenever I'm factoring a trinomial, the first thing that I should always look for is a GCF. Number 1. Number 2, if there are 4 terms, I should do what? By grouping method. If there's 4 terms, I want to factor by grouping. Number 3, if there are 2 terms, check and see if I can use the difference of squares. Difference of 2 squares. And then if it's 3 terms, a trinomial, I want to do the whole, are they perfect square trinomials, or do I have to use the A times C method? That's a lot to remember. That really is a lot to remember. Let's try it. So factor completely. Factor completely. So take out a GCF. We already said that. If there are 2 terms, check to see if you can use dots. Remember, both terms are perfect squares. I'm just going to write perf squares. They're joined by a minus. Okay. If you have 3 terms, you have to decide, is it going to be the AC method that you learned yesterday? Or are they perfect square trinomials? 4 terms, we use grouping. 4 terms grouping, okay? Thoughts? Okay, so we're going to do 3 on the front page, and then I'm going to pick 5 on the back page. So I definitely want to do example 13. Quali. I want you to look at example 13 and tell me, do you think that there's a GCF in there? Because that's the first thing that we're supposed to check. Are they both even? 8 and 72 are both even, right? So that means it's definitely divisible by 2. Are they both divisible by 4? I don't know. Let's check. Here's how I do that. 2. Do you see the number 72 in there? No, because it's too small. What about 4? Do you see the number 72 in there? Yeah. What about 8? So can we divide them both by 8? Yeah, that's my GCF. I have a GCF of 8. Take that out, and then your leading coefficient is 1. Right? So let's take that 8 out. That gives me x squared, minus 9. Now I have 2 terms. If I have 2 terms, what do I have to check for? Dots. Are both of those perfect squares? Yep. What's the square root of x squared? X. What's the square root of 9? 3. Join one with a and one with a. Perfect. Okay. Charlie, example 14. Do you see a GCF?
5.
Yeah, 5. Take a 5 out of that. So I'm going to divide everything by 5. 5 equal, or 5 times x squared minus 10x plus 25. 3 terms. AC method, or do you see that this is a perfect square trinomial? It's not dots. Dots is difference of 2 squares. This is a perfect square. What's the square root of 25? 5. What's 5 times 2? Is that your middle term? Yeah. Oh my goodness. So this is going to be 5 times. See how this is negative right here? That means it's going to be x minus 5, the quantity squared. Could you use the AC method with this? Yeah, you're just going to get x minus 5, x minus 5. I mean, so if you don't recognize that it's one of those perfect square trinomials, you can use the AC method for sure, okay? What about this next one? How many terms? 4 terms. Okay, so, grouping, I heard someone say. Polly, was that you? Good job. Okay, so what can I take out of the first grouping? Just an x squared. Yeah, what can I take out of the second grouping? A negative 9. Good job. So I have x squared times the quantity, let's see, 2x cubed divided by x squared is just 2x. X squared divided by x squared is 1. Minus 9, let's see, negative 18x divided by negative 9x is a positive 2x. Negative 9 divided by negative 9 is a positive 1. Do I have my repeat, my copycat? I sure do. Copycat comes out first. 2x plus 1 times, x squared minus 9. What do you see about this? Yeah, that's a difference of 2 squares. I have to break that x squared minus 9 down. That's pretty crappy, right? That's pretty shady that we stick that in there. What does x squared minus 9 break down to? Well, what's the square root of x squared, sorry, and what's the square root of 9? Join the middle with a and a. Don't forget about your first 2x plus 1. This has 3 factors. Why is that? Any ideas? What's the exponent, the degree of this? What is the degree up there that I just circled? 3. This is a degree 3 polynomial. Degree 3 has 3 factors. Interesting. But when it's a degree 2, how many factors do we have? Do you think that that's for on purpose? It is. Yeah, so that'll kind of tell you how many factors you need to have. So look at this hot mess right here. What is this? Yeah. How many factors should that have? Yeah, we're not doing that one. It takes a whole page. We're skipping it. Okay? All right, on the back, we have to solve. So now we're solving. So we're not factoring anymore. We're solving, okay? So that means we're going to have to factor. Find the factors, set them equal to 0, and we're going to end up with an x equals something, okay? Using all of these methods. So the first one is already done for you. That's already in factored form. 3x plus 1 times the quantity 2x minus 5. So when I put this in factored form, when I solve this, sorry, I have 3x plus 1 equals 0 or 2x minus 5 equals 0. Okay? So what does that mean? Subtract 1. 3x equals negative 1 divide by 3, x equals negative 1/3. Or add 5, 2x equals 5, divide by 2, x equals 5/2. I'm really not showing the divide by 2 or the divide by 3, sorry. I just feel like we could maybe do without those, but okay. Does that make sense? Okay. Let's go to number, okay, I want to do 6. 6 you have to do by grouping. 7 is a grouping. Let's do 6, 7, and 8, and then I'll let you guys pick the last one. How's that? 6. What do I have to do first? First, I need to make it look like this. So I got to move this over here. Subtract it. I'm not even going to write it out. I just know that you guys know what to do. So 6x squared plus x minus 12 equals 0. Okay, so let's look at our factors. 6 times negative 12 is negative 72. The number for B is 1. What are two numbers that I multiply together to get 72 or negative 72 that when I add them I get 1? 8 and 9. Which one needs to be negative? 8 needs to be negative. Yeah. I don't know why I always smush them on the same side because I never used to use this. 8 and 9. 8 is negative. So this is a factor by grouping because my leading coefficient is not 1. So my factors are, when I write it in grouping, 6x squared minus 8x plus 9x minus 12 equals 0. Remember, all I did was, if you add these two together, if you combine like terms, negative 8x and positive 9x gives you the 1x up top. We're just rewriting it so it has 4 terms. That's all we're doing. What's the GCF I can take out of 6x squared and 8x? 2x, yes. What can I take out of 9x and negative 12? 3, okay. So if I take a 2x out of the first term, I'm left with 3x minus 4. Plus 3 times, when I take a 3 out of the second term, I'm also left with 3x minus 4. Do I have my copycat? Yes. Remember, we're setting these equal to 0. So I have 3x minus 4 equals 0, or my other factor, what's left over, is 2x plus 3 equals 0. Okay? So if 3x minus 4 equals 0, add 4 to both sides. That gives me 3x equals 4. Divide both sides by what? So x equals 4/3. Do you guys see you're just solving a two-step equation there? Okay. What about this one? 2x plus 3 equals 0. How do I get 2x all by itself? Minus 3. So I'm just going to do it. Is that okay? Now what? Divide by 2. So x equals negative 3/2. Can I tell you guys something? If your factor, if this is your factor, do you realize that your solution is always the opposite of b divided by a? Has anyone seen that, like that pattern? If your factor is ax plus b, if that's your factor, those just a and b just stand for integers, then your root is always x equals the opposite of b over a. Always. I think you should write that down. That'll make your lives much easier. Okay? Number 7. What are we going to do here? I know you guys are tired. I'm doing the fastest I can. Number 7, what are we going to do? Add 12. X cubed minus 3x squared minus 4x plus 12 equals 0. How many terms are there? 4. Means I have to factor by? Okay. I don't have to use the times plus chart or anything. It's already done for me. So let's see. What's the greatest common factor I can take out of the first one?
X squared.
Yeah. What can I take out of the second one?
2.
How about a 4? Okay. I think I'm going to take out a negative 4. So when I take out an x squared, let's see, I'm left with x minus 3 minus 4 times negative 4 times negative 4x divided by negative 4 gives me a positive x. 12 divided by negative 4 gives me negative 3. Copycat, x minus 3 equals 0. Or, what about this one? X squared minus 4. Is this factored all the way? No, this factors into what?
X plus 2, X minus.
Yeah, difference of two squares, x plus 2 and x minus 2. So we have x equals positive 3, x equals negative 2, or x equals positive 2. Why does this have 3 factors? Or sorry, 3 solutions? Because it's cubed. It's degree 3. It's degree 3. That's why. Okay, I can tell you guys are done. You're done. Here's what we're going to do. I scanned these. Okay, I scanned these and they're posted. I'm going to stop the video.